In this video, we will discuss about the different transistor connections or different modes of connecting the transistor in a circuit. We already know that transistor has three terminals in it, and those terminals are called as emitter, base, and collector terminals. Okay, but in any circuit, there will be two input terminals and two output terminals. That means we need four terminals for providing input and to receive the output actually in any circuit. Because of these three terminals in a transistor, so there is a technique used to make four terminals effectively in a circuit. So what we are going to do to overcome this difficulty, one terminal of the transistor can be common for both input and output. Okay, so any one terminal can be made both common for input and output. So based on that, so there are three ways of connecting the transistor in a circuit. So they are common base mode, or it is called as CB mode, common emitter mode or CE mode, and common collector mode or CC mode. Common for both input and output. Whereas in common emitter mode, the emitter terminal is made common for both input and output. And in common collector mode, collector terminal is made common. So let us take the discussion of the common base mode in this video, and in the next video, we'll take up the discussion of common emitter mode. Let us take common base mode of the connecting the transistor in a circuit. So in this circuit arrangement, basically input is applied between emitter and base terminals, and output is taken from collector and base terminals. And you can clearly see base terminal is common for both input and output. So in this circuit, base of the transistor is common to both input and output circuits, and hence it is called as common base connection. Okay. So how this common base connection looks like? So this is the simple circuit showing the common base connection of the transistor. Okay. So this is the NPN transistor we have used here. This is emitter, this is base, and this is collector. This is NPN. Okay. So when NPN circuit is connected, transistor is connected in the circuit, we know that this emitter base junction has to be forward biased. So we are using this battery VEE to make the emitter forward biased. It is a NPN transistor, so emitter is N type, it is connected to the negative terminal. Second condition is collector base junction should be reverse biased. So collector is again N type, it is NPN, so collector is N type. So that N-type terminal is connected to the positive of the battery, so that collector terminal becomes reverse biased. So here one extra resistance RC is connected to the collector. We call this as the collector resistor, okay, or collector resistance. So across that resistance, the output is taken. Okay, if you look at the circuit, this base is common for both input and output. This is made common. It is also connected to the input and it is connected to the output also. So that's why this base is common for both input and output. Whereas the emitter is clearly input terminal and collector is the output terminals. Okay, terminal. So now let us take what are the input parameters and output parameters in this circuit. So here, if you look at the input circuit here, what is the current flowing through the input circuit? That is emitter current IE. So IE is called as input current. Whereas the input voltage is voltage between emitter and base, because input is given across emitter and base terminal. That is the reason why the input voltage is basically VEB. So EEB stands for emitter base. Okay, it is the voltage between emitter and base. In the output circuit, if you look at the output circuit here, the current flowing through the output circuit is IC. So IC is the output current, and output is taken across collector and base terminal. So that's why the output voltage is VCB, that is voltage between collector and base. So here the letter B is coming secondly, that means it is a common base mode connection. So VEB and VCB are the input voltage and output voltages respectively in common base mode. Okay, so this is the nature of the circuit or type of the circuit which represents the common base mode connection of the transistor. Okay, so let us study what are the characteristics of this common base mode connection. Okay, so for that these input parameters and output parameters are required. So here we have shown that the input current is IE and input voltage is VEB, output current is IC and output voltage is VCB. So these are required for understanding the characteristics of CB mode. So let us discuss the characteristics of the common base mode connection of the transistor. The complete electrical behavior of a transistor that can be described by the interrelation between these input parameters and output parameters. They are actually called as input current, input voltage, and output current, output voltage. So relationship between them can be studied by drawing the graph between them, and they are also called as VI characteristics, that is voltage current characteristics. Okay, so how voltage and current are related in the input circuit and how they are related in the output circuit. Based on that, we can understand the characteristics of transistor in common base mode connection. Okay, so most important characteristics of the transistors in common base mode are input characteristics and output characteristics. So basically, input characteristic is it is the relationship between the input voltage and input current. So basically, the input characteristic is the graph between input voltage and input current at constant output voltage. Okay. So while studying the input voltage versus input current, the output voltage should be kept constant because we are focusing on the input VI characteristics. So at that time, there should not be any change in the output because input and output are interrelated. If output voltage changes, that will influence the input characteristics. That is the reason why while studying the input characteristics, output voltage should be kept constant. Okay. So basically in CB mode, the input current is emitter current and input voltage is the emitter base voltage VEB. Therefore, for common base mode, the input characteristic is the curve obtained by drawing the graph of emitter current IE versus emitter base voltage VEB at constant output voltage, that is VCB. Okay, so this graph is actually called as the input characteristics. Okay, so basically the emitter current, if it is related to emitter base voltage, it looks like this. Okay, so here we have shown two curves. One curve is for VCB is equal to 0 volt, another curve is VCB equal to 10 volt. So when you keep VCB constant, then it is observed that with increase in emitter base voltage, the emitter current will increase rapidly. Okay, so suddenly there is an increase in the current when you reach above 30 volt. Up to 30 volt, there is a linear behavior or linear variation, then it will increase suddenly. Okay. A parallel curve is obtained for another value of VCB that is equal to 10 volt. Okay, so what happens when output voltage increases? The variation of emitter current starts at higher value. Okay, so this is how this emitter current and emitter base voltage are related to one another uh, in the input circuit. So usually the emitter current is taken along y-axis and emitter base voltage is taken along x-axis. We have shown here. It is in millivolt and this is in milliampere. So very small change in emitter base voltage can cause a large change in emitter current. Okay. So what is the information you can get it from the input characteristic is that you can calculate the resistance of the device by taking the 1 by slope in the linear region. Okay. So here it is observed that the emitter current IE increases rapidly with a small increase in the input voltage VEB. Okay, so there is a large variation of current with small variation of voltage. The emitter current is observed to be almost independent of the output voltage. Okay, the output voltage will not influence much on the input current. So from this graph, you can calculate the input resistance of the transistor. Basically, input resistance is the ratio of change in input voltage to the change in input current at constant output voltage. So that is actually the change in emitter base voltage divided by change in emitter current. That should be taken at constant collector base voltage. That is the output voltage. So input resistance is given by delta VEB divided by delta IE at constant VCB. So that is actually 1 by slope. If you take the slope here, that will give you delta IE divided by delta VEB. Okay. So it is observed that for small change in V, there will be large change in I. Okay. So delta VEB is smaller, delta IE is larger. A smaller value divided by a larger value gives you a small value. So it shows that the input resistance of the transistor when it is connected in CB mode is observed to be very small. Okay, it is of the order of very few ohms. So input resistance is small when transistor is connected in CB mode. That is the information you can get it from the input characteristics. Let us take the output characteristics of the transistor in CB mode. It is basically defined as graph between the output voltage and output current at constant input current. So when input current is constant, then how the output voltage and output current are related to one another. That graph is called as output characteristics. So in CB mode, the output characteristic is the curve between collector current IC and collector base voltage VCB at constant emitter current, because here output current is IC, output voltage is VCB. Input current is IE, that is emitter current. Okay. So to draw the output characteristic, usually we take collector current along y-axis and collector base voltage along x-axis. Okay. So here you have to keep the emitter current constant. So you know that emitter current is always equal to sum of base current and collector current. And base current is very small. That's why the emitter current is nearly equal to the collector current. Okay, so IE will be nearly equal to IC. If you keep this IE constant, then IC will also become automatically constant. Okay, so what happens? This curve between collector current and collector base voltage will become a horizontal line after small increase in the voltage. Okay, if you take IE equal to 1 milliampere, you will get the curve which is taking the value 1 milliampere horizontal, which is touching 1 milliampere here. So for 2 milliampere, it is exactly reaches 2 milliampere, it remains constant. For 3 milliampere, 4 milliampere, and 5 milliampere are shown. That means there is no change in current even if you change the voltage. So from this graph, you can obtain the value of output resistance. Okay. So basically the collector current IC varies with VCB at very low voltages only, that is less than 1 volt. After that, the collector current remains constant. Okay, when collector current remains constant, there will not be change in collector current, even if you change the value of VCB. Okay, so what happens after 1 volt? The collector current will only depend on the emitter current I. It will become independent of VCB. So whatever may be the output voltage, the output current remains constant. Okay, so that means even if you change the voltage by large value, the change in the output current will be very, very small. Okay, if you calculate the output resistance, that is delta VCB divided by delta IC, change in output voltage divided by change in input current, sorry, change in output current, that is going to be very high because delta VCB is very large, delta IC is very small. Okay, so output resistance is delta VCB by delta IC. Here, even if you change the value of VCB by large value, the value of IC remains constant or change in IC is very small. It is the ratio with large value divided by a small value. It gives you the output resistance of the transistor as very large value. So it is observed that the output resistance of the transistor in CB mode will be several tens of kilo ohms. Okay, 10, 20, 30 kilo ohm like that. So this is not surprising because the collector current changes very slightly with the change in VCB. Okay, because high resistance means there is no much current to flow, or there is no much change in current. Okay, so since IC is constant, because of that, the resistance leads to or tends to increase if the output voltage increases. The another important characteristics of the CB mode transistor is current amplification factor, that is represented by alpha. So basically it is the ratio of output current to input current. It is simply output current divided by input current in the circuit. In a common base mode, the input current is observed to be emitter current IE and output current is observed to be the collector current IC. So that's why, according to the definition, the current amplification factor is defined as the ratio of change in collector current to the change in emitter current at constant output voltage, that is collector base voltage VCB. Okay, mathematically you can represent this as alpha is equal to delta IC by delta IE, that is observed at constant VCB. Or for calculation purpose, you can take this alpha as simply IC by IE also. Okay, so here I have represented it as change in IC divided by change in IE, but you can take it as IC by IE also. So you can observe here, this emitter current is always equal to sum of collector current and base current. Because of that, this emitter current is always greater than the collector current. So here numerator is smaller compared to the denominator. So denominator is greater. So IE is always greater than IC. So that's why this ratio has to be always less than unity or less than 1. So it is observed that the practical value of alpha in practically commercially used transistors is ranging from 0.9 to 0.99. It is just less than 1. Okay, so usually alpha is used for representing the current gain or current amplification factor in common base mode. Similarly, beta is used for current gain for common emitter mode, and gamma is used for current gain in common collector mode. Okay, while discussing the common emitter mode, we'll discuss about the current amplification factor beta also. So this alpha is basically representing the current gain for common base mode of the transistor. Okay, so these are the important characteristics of common base mode. And to understand the common base mode connection, these characteristics has to be understood properly. So in the next video, we'll take up the common emitter mode connection of the transistor.